Today, we're going to solve a fascinating cube equation that reveals an elegant mathematical pattern. Here's our equation. X cubed equals 303 cubed plus 404 cubed plus 505 cubed. At first glance, this looks quite complex, but there's a beautiful pattern hiding here. Let's look closely at these numbers, 303, 404, and 505. Notice anything interesting? Each of these numbers follows a specific pattern. Let me show you what I mean. 303 equals 3 times 101. 404 equals 4 times 101. And 505 equals 5 times 101. Do you see it now? Each number is a multiple of 101, and the multipliers are consecutive integers, 3, 4, and 5. Now we can rewrite our equation by substituting these factored forms. So x cubed equals 3 times 101, all cubed, plus 4 times 101, all cubed, plus 5 times 101, all cubed. Here comes the magic. We can factor out 101 cubed from each term. This gives us x cubed equals 101 cubed times the quantity 3 cubed plus 4 cubed plus 5 cubed. Let's calculate that sum step by step. 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Adding these together, 27 plus 64 plus 125 equals 216. Now here's the key insight that makes this problem beautiful. 216 isn't just any number, it's actually 6 cubed. This is no coincidence. Substituting back, we get x cubed equals 101 cubed times 6 cubed. Using the power rule, when we multiply powers with the same exponent, we can combine the bases. This becomes 101 times 6, all cubed, which equals 606 cubed. Therefore, our answer is x equals 606. Let's verify. 606 cubed does indeed equal 303 cubed, plus 404 cubed, plus 505 cubed. This problem showcases the elegance of mathematics. What seemed like a complex calculation revealed itself to be a beautiful pattern involving consecutive integers and perfect cubes. Sometimes the most beautiful solutions come from recognizing the hidden patterns in what appears to be chaos.